Hello, everyone. Welcome to TBC 2021. Today, we are going to present the Synchrony success story implementing a modern switch. We have two presenters. We have Vikas Katok, who's the Vice President of POS Credit Services, and I am Yash Kapadia, the CEO of Omni Payments. Our agenda for today is split into a couple of very distinct areas. We will first have Vikas present the company an overview of Synchrony, so we get to know what Synchrony does. Then I will present the Omni Payments overview, so we get to know what Omni Payments does. Following that, we will get into discussions about how we implemented the Omni Payments solution for Synchrony. We will get into technical details on the JSON message flow. And once again, we will come back and summarize the business benefits of why Synchrony implemented the Omnipayment Switch and what did they get in return. So at this point, let me turn it over to Vikas. Vikas, here's your slide on the company overview.
Thank you, Yash, and good morning, everyone. We started working with Omni Payments 3 years ago. We are a largest private label credit card issuer in US and dual card. We're based out of Stamford, Connecticut. We have few locations. One, our biggest, second location, it's in Hyderabad, India, where our developers and our support staff sits. Then we have my team and other development team onshore that sits in Chicago, Illinois. So we started this journey 3 years ago, like I said, with Yash and team. We first wanted to get rid of our our G file, what we call our VB-based software front end, which was very, very heavy and took forever to install, implement, and distribute. So we went out to Omni Payments and they suggested to run it on the nonstop. So we worked on that. Then we started working. Then I came to Yash and say, hey, Yash, we need to work on another project where we need to modernize our ISO flow, our ISO 8583. Today we use a packet system. We want to use XML, JSON, and build APIs. And at that time, Yash and team helped us get Omni Web Services. As we started getting more modernized and more and more requirements came, like data at rest to be tokenized, more APIs, build our application APIs, not just authorization APIs. And at that time, we decided, again, bug Yash about getting us another solution, which he has implemented in many other banks. And so they came on, I believe it was 2019, and presented us with Omni Switch, which was perfect for us, where they would consume our existing code, our existing business rules, and modernize our stand-in, our auth flow. So we decided to go with Omni at that point, and we divided our project into two phases. Phase one is obviously authorization, and the second is our acquisition side of the house, which is application authorizing. Yes. So at that time, because due to COVID, we could not start our project on time, obvious reasons. And first of all, Yash, thank you very much to be patient with us. And again, Vineet and Vaman, Nikita, Vaibhav have been so fantastic and so much patience. I know it was a tough start, but we finally started. Yash and team came, took all our requirements. Turns out we didn't have all the correct documents. And please keep in mind, because this was a very, very old system that we inherited from GE, almost 30 years, and needed to be modernized. So they helped us document, go through our code, review it, documented, represented it, we went back and forth, and all remote, and there were some challenges, but they helped us all through getting all this documented. A lot of clients, which are like Amazon, Cathay, Cheapo Air, who wants everything web services based. They do not want to have direct links into our data center. They want to do all the business through internet. So obviously we needed to modernize our system. And at that point we decided, okay, web service is it. So we went to Yash. They helped us build all these APIs for Amazon. And now Yash, as you already know, Walgreens is one of our big client now. We're working with them. We started taking their authorization. They're also consumed our API. So again, Yash, thank you very much for helping us to get where we are and modernizing our system. I'll give this back to you.
Technical challenge, and we're excited. Thank you so much, Vic. So essentially, our journey now is we are deploying customers in the Omnipayments cloud. We are deploying things with mobile payments, with tokenized cards, uh, all of those things that you need in a wallet. Now, here is an overview of how the company started out and what is our mission. So basically, we are now 26 years old. We have customers around the world. We are a multinational company. We have offices in Silicon Valley, uh, Dallas, Chicago, Puerto Rico, several countries in Latin America, Mexico, Colombia, Chile. In We also have offices in Europe, and our biggest office is the development center in India. We have 4 development centers in India, and so the company has grown quite a bit. Our mission is to provide low cost, flexible, intelligent payment services. And so those are keywords. Low cost, it's our mission to make sure that we provide our solutions at a reasonable price. We've deployed everything using open libraries and using modern tools. So as a result, we are flexible. And one of the key differentiators between us and the competition is we deploy all of our solutions on the HPE Nonstop platform. So deploying these solutions on the HPE Nonstop platform gives us the high availability, the 5 nines of availability that you get from an HPE Nonstop server. So we provide low cost, flexible, intelligent, continuously available solutions. And we are very flexible. So we use our software factory to customize the solutions for you. As a result, we are able to optimize the transaction based on the way you want it to flow and based on each customer interaction. Now, let's take a look at some of the challenges that Synchrony was facing. As Vikas explained to us earlier, Synchrony had the GE application, which was built almost 20 years ago. And so this application, while it was very powerful, it had uh, it had outdated itself. The entire software is written in COBOL. It is complicated. It is difficult to add new interfaces to make changes. And so what Synchrony wanted to do was Synchrony wanted to implement a modern framework. And as Vikas explained to us earlier, the new customers are demanding web services. So the new customers wanted JSON APIs, and they wanted to be able to then connect to Synchrony's core systems. But the front end had to be JSON APIs. The back end was reuse the existing Synchrony applications. So what Omnipayments did was Omnipayments provided a quick JSON interface to be able to satisfy these requirements for Synchrony. Now, here is an architectural diagram of the Omnipayment Switch. The Omnipayment Switch is modular. It has multiple layers, multiple interfaces. It's easy to plug and play and build what you need. So as a solution, the Omnipayments interface connects to all the front-end devices. It connects to the ATMs, the POS devices. It connects to the electronic banking systems, and so the Omnipayment system is flexible to accept input messages from the acquirers in JSON message formats, in web services, in Microsoft, in Azure, in also in the standard ISO. Once the message gets into the Omni messaging system, we first check the message for fraud, and that has been a very big benefit because we are checking fraud in real time. We are not checking fraud after the transaction has been processed, so we are blocking fraud in real time. And that differentiator has been very valuable for many of our customers. As we are all aware, fraud and cyber attacks are increasing, and so being able to eliminate the fraud upfront is extremely important. So once we go through eliminating the fraud, then we switch the transaction. We pass the transaction to the issuer, so that could be Visa, MasterCard, it could be Fiserv, it could be any of the host authorizers. And once the transaction is authorized, then we pass the information over to the compensation settlement process, and the compensation settlement process will then calculate all the fees and all the money that has to be paid to the merchants. Now, all of this, the entire solution is extremely powerful and implemented on the HPE nonstop servers. And then the approach we've taken is we are leveraging industry solutions such as Splunk, other big data solutions for data analytics and for business intelligence. So we feed the data out of the nonstop server into a Linux platform, and we run all our big data, Splunk, everything on a Linux platform. So as a result, the solution is extremely modern. You get all of the benefits of having the high availability nonstop platform and all of the benefits of having new modern solutions in the open world. Now, here is an example of some of the modules that we are in the process of deploying at Synchrony Bank. As Vic explained to us, the very first module that started out was the JSON services. So we provided web services. After providing the web services, Synchrony was happy with our solution and they started implementing the switch. Now, as we were implementing the switch, we found that there was huge benefit to implementing the fraud blocker. So Synchrony implemented our fraud blocker solution. And through this entire journey, of course, there is need for stand-in, there is need for compensation, there is need for dashboards. So these several modules were added into the project in a modular way, which allowed Synchrony to make decisions, start with the solution early, and as the business evolved, they were able to make further purchases and keep adding the modules. I will go through the modules very quickly. So starting at the top is the switch, and to the next to the switch is the Visa value-added services. We bring in the Visa value-added services modules when we want to implement solutions such as Visa Direct, person-to-person payments, Visa CyberSource, Visa Tokenization. If you want a network token, then we can implement Visa Tokenization for you. If we are looking at purely maintaining acquirer tokens, then Omnipayments provides a secure token vault. And so transactions are never stored in the database in the clear. Transactions are always stored encrypted. We provide our dashboard solution, which runs on Linux. And so while we keep the nonstop server extremely secure, we provide end customers access into the dashboards, and they can run their own reports. They can run they can do joins on the database. They can prepare their own set of reports. They can prepare their own dashboards. And the entire solution then is integrated with SMS and email alerts. So while you can see alerts on the dashboard itself, you can also get an email or an SMS when things go wrong. Now, in our business, we've always known and we've always implemented active solutions. So in our telco solution, we had triple redundancy. We had an active setup. In the banking industry, what we've seen is that the typical standard is to have an active or an active passive system. So in the event that the customer wants a hot standby, we will implement the active passive system, but otherwise we recommend the active active. Now, to synchronize the data between the two non-stop systems, Omnipayment ships its own replicator that's called the Omni Replicator, and that is a separate module that you can add on to the application at any point in time. The entire solution comes with APIs. So if the customer needs to have web services or JSON interfaces as Synchrony needed, then in that scenario, we implement the API module. CMS is our card management solution. The mobile app is a wallet that gets deployed on your iPhones or on your Android phones. And the mobile app is then used subsequently for Visa direct payments, for home banking, for NFC contactless payments, for all kinds of different mobile payments. The stand-in module itself is very important for Synchrony Bank. The stand-in module allows Synchrony Bank to maintain the customer balance in real time. And so if at any point in time the host processor goes down, if the issuing processor goes down, Synchrony Bank is still able to authorize the transactions using our stand-in module. They have the most current balance, and based on the most current balance, we are able to authorize the transactions and eliminate and reduce fraud. So the stand-in module has been very important and valuable for Synchrony Bank. Now, of course, when you are in the stand-in phase, you need to authorize. So we have the authorization module, which allows us to authorize the transactions. The fraud blocker module is important for us to eliminate fraud. And the fraud blocker module is a standalone module that can be added as a complement to Omnipayments, or it can be added as an add-on module to an existing base24 system or any other system. Now, some of the other modules that we have are things like fees and settlement, where we calculate the compensation, we calculate the amounts that are due to the merchants. And one of the new solutions that is in the process of being implemented is a person-to-person payment solution. Using the person-to-person payment solution, we are able to send cross-border payments from workers in the United States to their families in Latin America. We're able to send payments for last night's dinner. If I went out with my friends last night and we want to pay each other, we can send the payments using our person-to-person solution. And in that, we've integrated with Visa and MasterCard. And so we are able to send payments to Visa, MasterCard customers in real time. And the transactions, the money shows up even cross-border in less than a few minutes. So these are some of the Omni modules. Synchrony Bank has implemented many of these, and we are in the process of implementing some of them. Now, here is a diagram of how we implemented the Open API framework. So the Open API framework, it basically, if we see on the right-hand side, we have the typical Synchrony applications. We have the sign-on application, the account inquiry, the statement inquiry. And I've kept things at a very high level so that at no point are we violating Synchrony Bank's intellectual property. But if you need more details, we can always arrange a call with Vikas, and Vikas can share with you more details about the Synchrony application. So the Open API framework, what it does is it gets JSON messages, it gets SOAP messages, XML messages. These messages come in as an input into the API gateway. And from the API gateway, then we route the JSON messages to the JSON adapter, and we route the SOAP XML messages to the XML adapter. Here is an example of how we integrate with the Azure Web Services. So basically, if customers are using the Azure cloud, they can easily invoke our Azure instance, and the Omnipayments Azure instance will then route the transactions over to the nonstop servers which run in the Omnipayments data center. And these nonstop servers connect to the Visa, MasterCard, and provide the high availability. So essentially, we can support modern applications that are using Azure services, using our APIs, using the Omnipayments APIs. And if you want to take it a step further, we can even use the Omnipayments data center, which is called Omni Cloud X. Now, it's extremely important that customers have the flexibility to use modern tools. And so, if you've seen in today's world, uh, customers test their applications using open APIs, using tools such as Swagger. So, for our customers see a Swagger screen. They use Swagger to test the Omni Payments application, and to they do not ever need to know that they are logging onto a nonstop server. So this has been extremely important for us. Now, here are some more technical details about the JSON flow. The solution is fully active. There is load balancing, so messages can go to either of the nodes. And internally, we also handle load balancing between different components within the bank. So in the event that one of the Synchrony servers at the backend is down, we are able to fail over to the other Synchrony server. And so as a result, with this extremely high availability solution running on two nonstop servers, running on multiple Linux servers with failover, we are able to guarantee several nines of availability. So while all these are web services, the deployment is very simple. We put in the Omnipayments API interface, the API module, and that then leverages the power of the nonstop servers. Okay, so here is another example of how we invoke the Synchrony pathway servers. So while we send all the web services through our API gateway, standard legacy packets come to us, and those are delivered directly into the Synchrony pathway servers. So in this message flow, we have been able to leverage Synchrony's existing servers. We did not have to throw away their intellectual property, did not have to throw away their investment. We were able to modernize the entire pathway application by introducing Omni Payments components in front of the application. Now I'm going to switch over into tokenization. These are these are extremely important standards for today's PCI world. When you go in for your PCI audit, the first thing that comes up is the PCI auditor will ask you, do you store the cards in the clear, or do you tokenize the cards? So we provide tokenization within our system, and cards are never stored in the clear. We use the Omni tokenization solution. In addition to this, we provide tokens so that you can implement these tokens in your mobile phones, and these tokens then get stored in the mobile wallet, so the card itself is not stored in the mobile wallet. We also have these tokens, and we can implement network tokens with Visa. So network tokens are the scenario where an issuing bank issues a network token. So Visa will deliver the network token to us, and we will deliver the network token to your mobile wallet. So there are two levels of tokenization. One is tokenization within Omnipayments itself, where we deliver tokens to our acquirers, or we deliver tokens to our e-commerce partners. And the other scenario is where the customer wants to use a network token, which is issued by the issuer. And so the issuer network token is passed through Visa, through Omnipayments, all the way down to the acquirers. Tokenization is extremely important, and as we go forward, we are going to see cards are used less often, and tokens are used in a majority of the transactions. So in addition to tokenization, we also support one-time card numbers, and the one-time card numbers are very secure, because you essentially use that token once to make your purchase, and then that card number can never be used again. So these secure tokens, the one-time use tokens, are also delivered using the Omni Payments tokenization process. Now, some of the other benefits that Synchrony got from the solution are they got a modern solution which is completely integrated with modern platforms. So let's take an example. From the nonstop server, Synchrony wanted to export all of the transactions over to a Kafka system. And the Kafka system then runs business intelligence, and there are other applications that use the data delivered to the Kafka system. So Omnipayments delivers these messages from the Nonstop system using the Omnipayments Kafka adapter, and these messages are then delivered over to a Kafka server. So we have the producer running on Nonstop, and the producer will then generate the messages and deliver them over, and other applications will read off a topic. They will consume the messages delivered on a topic and run the business intelligence on that. So these are some of the examples of the benefits that Synchrony Bank has got by using a modern solution. Another example is all of our information is delivered using SNMP. So we're using SNMP, we can deliver SNMP to SNMP monitors, to HP's non to HPE's SNMP monitors, or to open source Nagios monitors. So for example, one of the open source SNMP monitors we've integrated with is called Nagios, and Nagios is extremely powerful. It is inexpensive, and so now we are able to take all of the SNMP events from the Nonstop, events such as application start, application stop, abends, TCP/IP status, socket connected, socket disconnected, file full. We're able to take all these SNMP events and pass them over to Nagios, the open source SNMP monitor. We are also able to pass things related to your Nonstop console. So everything that your Nonstop console is monitoring, such as the ILO, right? The ILO is monitoring the CLIMS. The ILO is monitoring all the TCP/IP CLIMS and the storage CLIMS. It's monitoring the CPUs. So all of these events, all of these SNMP events, we get them out of the ILO and we pass them over into the SNMP monitor. So that's another example where we've taken standard open source solutions, integrated them with the Nonstop, and reduced the total operational cost of the solution. Now, I'm going to touch a little bit upon the graphs, dashboards. And so essentially what we've done is we export all of the transactions in tokenized form over to the Linux servers. So the Linux servers could be running Splunk, they could be running Pentaho for business intelligence, they could be running the Matplotlib for graphing software. And so all of this information is exported out of the Nonstop server into these different solutions. We also export the data out to an Oracle database, so we can replicate from the Nonstop into Oracle, and we replicate the transactions, we replicate the log files, we pass all this into an Oracle database. So then from Oracle, then you can use other Oracle tools to run business intelligence on your on the payment flow within the Nonstop system. And what we've also done is we support MySQL. So on the one hand, you can of course have Oracle and the power of Oracle. And if you are looking for an inexpensive solution but still powerful, then we can use MySQL. So Omnipayments has deployed the entire solution on HP Nonstop equipment for the high availability, and yet at the same time it is integrated with all the open source solutions so that we can provide uh, a lower cost for the entire solution. Now here is an example of the OmniSPlunk adapter. So basically what the OmniSPlunk adapter does is it picks up information from the various subsystems on the Nonstop server. It takes this information from the Nonstop server and sends it over to Splunk, and so you can see your graphs in Splunk. Now, the graphs that we are seeing over here are CPU related. So you're seeing CPU busy, disk space usage. Let me get into some more technical details on how this has been implemented. So essentially, we pick up events from the EMS distributor. We take these EMS events and pass them over to Splunk. So now in Splunk, you're able to monitor EMS events, and EMS events could be process started, process stop, it could be transaction log files, whatever you put in your EMS collector. In addition to that, we have sensors, and we call them sensors. So we have a sensor for an OSS log file. We have a sensor for a SQL MX table. We have a sensor for an inscribe log file. So using these sensors, we can pick up transactions from the log files, whether they are OSS, audited, non-audited, whether they're inscribed, audited, non-audited, or whether they are SQL MX or SQL MP. We can pick up data from all of these different files and pass it over to Splunk. The other thing we've implemented is OLMs. The OLMs are operational logic modules, and these operational logic modules run a string of commands and a string of operations to check the health of the different applications and the subsystems in the nonstop. And based on these operational logic modules, we can make decisions and pass the data over to Splunk. So an example of an OLM could be a tackle macro. An example of an OLM could be a program that spawns processes, that handles process persistence. An example of an OLM could be uh, a registry process, which keeps track of all the different processes that are running in your system. So all of this information, we pick it up using our OmniSplunk sensors. We pass all this information over to a Splunk system, and as a result, the customer is able to, at a very inexpensive price, they're able to get to take full advantage of Splunk, take full advantage of the open servers, take full advantage of open solutions, and yet get all the transactions out of the powerful non-stop system. So with the OmniSplunk adapter, we are able to feed information to open source tools such as Splunk. We can use the same architecture, the same solution to feed data into Oracle. We can use the exact same thing to read base24 files, right? So essentially, if you have anything that's running on the nonstop system and you want to externalize it and modernize it and feed it into Splunk or Pentaho or big data solutions, then we can use the same architecture. Now, a little bit about the wallet. So the wallet is something that is extremely important because as we are seeing today, uh, payment systems essentially consist of point of sale solutions. They consist of e-commerce. And of course, when you discuss e-commerce, you have wallets and consumers are using wallets. So in Synchrony Bank's case, a lot of their customers are now demanding web interfaces and want to use AWS and solutions of that type. The wallet, the Omni Wallet, gets deployed on your iPhone or on your Android, and the card is tokenized within the wallet. So once we go through that process, the card itself doesn't travel in the clear. So all transactions, all the way from the wallet to the e-commerce site into the Omni payment solution and over onto Visa or MasterCard, through that entire process, everything is tokenized. Now the wallet itself, it handles things like sending money, person to person payments, using QR codes, requesting money from your friends, loading money using a credit card. It has all the information for your transaction history, and it can also support recurring bills and payments. So for example, we can store the card on file, and once we have that tokenized card on file, then we are able to use the token to generate your monthly statements and generate your monthly bills and pay for your monthly services. So this entire solution can be deployed for an acquirer or for an e-commerce website. It can be deployed at the issuer case, and it can also be deployed as a processor. I'm going to touch a little on the Visa value-added services. These are important for Synchrony Bank as it's simplifying the architecture for Synchrony Bank. So it as some of the solutions that are available are Visa tokens, which are network tokens, which allows then a network token to move across all the way through the issuer, all the way from the issuer bank, all the way to the mobile wallet. Then we have Visa Direct. We are able to integrate with Visa CyberSource, and of course, we have standard Visa ISO support. Now, all of these are add-ons in addition to what one would normally do. So in addition to the Omni Payments Fraud Blocker, if we want to in future implement the Visa CyberSource service for Synchrony Bank, that is an option. That's a module which we will just plug in. So let's take a look at the benefits for Synchrony Bank. As I've described through this presentation and as Vikas explained to us earlier, the important things for Synchrony Bank were to implement web services, to implement XML JSON web services, to still keep the power of the traditional ISO processing, then to be able to get the real-time balance for authorizations so that at any point in time they know exactly what is the available balance for a customer. We've then modernized the solution to provide and deliver all of the transactions that are processing within the system to a Kafka interface in Synchrony Bank. And they've got huge savings through reducing the operational costs, as well as using our replication software. And the biggest savings come from being able to block fraud. So the Omnipayments fraud blocker is helping Synchrony Bank save on fraud. Now, all of this information is stored for several months, so the history can be stored for up to 3 to 7 years. The online information is available for 6 months to a year, depending on how much disk space you have. And the entire solution is monitored using dashboards and the real-time activity monitor. So these are all of the benefits that Synchrony Bank has got as a result of modernizing using the Omnipayments infrastructure. I thank you for your time. And if you have any further questions, please do not hesitate to contact us. We will be more than happy to answer any questions. Here is the contact information for us. Thank you so much for attending today's presentation and look forward to hearing from you.